It's key to understand how binary numbers work so you can then apply it to learning how to subnet and how to calculate host addresses and subnet masks. So the binary system is based on two values, ones and zeros. The bit value is based on a position from right to left. So as you move from right to left, the value increases by double. So if you set it to 1, the bit value is applied for that position. If it's 0, then the value is just 0. This is a binary table here. And so these are bit positions. This is 1 octet and 4 octets to a 32-bit address. So you have the bit position starting from right to left. There's a bit set to 0 or 1. There's only 2 values. So if the octet has a 1 there, that is equal to 1. If it's got another 1 here in this position 2, it's 2. And then 4, 8, 16, 32. So it keeps doubling right up to 128. So if you have all 1s set in an octet, you have to add all these together. So this binary table is real important to know as you're going through and calculating subnetting. So here's an example here. There's a 32-bit dotted decimal address. 8 bits times 4 octets is 32. So there's 8, 16, 24, 32. So the 4th octet is over to the right, and as we move to the left, it goes to 1 octet. So here's an example, 192, 168, 107. So I'm going to show you how to just do a conversion here so you know how the bits work. So here's the 192, 168, 107. So this is the binary format, and I want to convert it to decimal. So here, if I go 1, 2, 4, 8, 16, 32, 64, and 128, I'm only adding the last two, 64 and 128. That gets me to 192. And for 168, it's the same sort of thing. 1, 2, 4, and then on 8 position, it's a 1, so I have to use 8. 16 and then 32 is 1, and then 128 is a 1. So I'm adding those bit positions together, and that's 168. And 100 is the same thing. There's a 4, a 32, and a 64, and that gives me the 100. And the 7 is just the first 3 bits all set to 1, so I just add 1, 2, and 4 together. And that's basically how you convert it. It's very straightforward. But it's a key part of understanding as you go through how to do calculations. In this video, I'm going to go through classful and classless addressing. And there is a distinction. And through this, you're going to start learning how subnet masks affect network addressing. So to start with, classful addressing is an older addressing. And it's based on default subnet masks. They're fixed-length subnet masks that don't change, and they're assigned per address class. For example, Class A, this is the address range 1 through 127, default subnet mask of 255 or /8. These address classes are all the address classes for any address that you would ever get. So they're both public and private addressing. Class D is multicast, and that's for things like routing protocols, so it's reserved. And Class C is experimental, it's reserved as well. So as you go through the IP address range, you notice that where they start and where they end, and anything within this range of addresses is considered this class address, and these are the default subnet masks. So to start with, classful is Class C addressing. This is an example here of Class C address, and there's the subnet mask of 24 bits and a host bits of 8 bits. So with 24 bits assigned to the network, that gives you almost 2 million different network addresses, because it's 2 to the power of 24. And the host per network address is 254. So that's the maximum number of hosts you'll get from the 8 bits. That's based on binary math. An example, for instance, is 192.168.1.0/24. That's the default mask. So if you assign this host address 1.1, router will advertise 1.0. It advertises the network address with the default subnet mask. And here an IP address is comprised of a network portion, a host portion, and a subnet mask. So for example, 192.168.1.0, this could be subnet 1, and it's the 1 that's changing in that octet, the 3rd octet. The host interface is 1.1, and there's the mask. So this is the subnet mask here, and so it's masking off the first 3 octets is the network address, and the 1 is the host address. And if we go through, you notice that the 2 changes, so that's the 3rd octet, because that's what happens with a /24 mask. It's always the 3rd octet that changes, and the range is going from 1 through 255, and then on to the host address and such. So it's pretty much the same thing. And here's an example here of the addressing you'd use for classical, and there's the 1.0 subnet. That could be a WAN interface. Then there's 2.0 for this subnet between layer 3 switch and router. Then this is a bunch of wireless access points assigned to VLAN 100, and it's using 3.0. Then VLAN 9 could be a data VLAN, that's 4.0. And VLAN 10 could be another user VLAN, and that's 5.0. So there are the 5 subnets. They're really top level network addresses, but each one requires the router to route between the different numbers because they are different subnets. And then on to say class B addressing, and this time the subnet mask is shifted to the left, so there are more host bits available and there are fewer network bits available to the network address. So the number of hosts is jumped to 65,000 because it's 2 to the power 16 instead of just 254, and 16,000 network addresses. So there's no practical value for the number of hosts in any domain where you have 65,000 devices, network interfaces really, for a segment or a broadcast domain. So it's just not practical. And there's for an example of 172.16. That's within that class B address range. It's at /16, so that's the top level address, 00. And then the host address is an example B 1.1, for example. And the advertised address would be the network address, so it would be 0016. It'll actually, as a classful address, it will advertise the network address on a class boundary. In this case, because it's 16, it would take the first 2 octets, and that's what's advertised. So you can have a lot of different addresses, and it gets summarized to 172.16, and that's what's advertised. And again, this is the example of the subnet. So 172.16 is the network address, as you can tell right there, and 1.1 is the host address. And what happens, so 17 would be the next one. It's class B, it's a classful addressing. So now it's the 2nd octet that's changing and becoming a new subnet, and you could do that 1 through 255. And there's an example of another host address. And here's an example of addressing. So there's 172.16, there's 17, 18, 19, and 20. And that's the subnets. And with Class A now, the subnet mask is shifted right further over to the left now, and it's got 8 bits for the network, so there's only 128 network addresses. So that's impractical. You're going to need a lot more today than that. And the hosts are 16 million, so there's no practicality to it. If you're using it as classful, I mean, it's something you really have to subnet to use it in a practical way. So the network address will be 10, because there's the .8, so it's now subnetting the first octet. So the host address will be this one here, 10.1.1, and this is what's advertised, 10.0.0.0/8. So as the network portion, you can tell now there's a 10 subnet and an 11 subnet. And so it goes through them pretty fast, really. And that shows you how it's masking off the first octet. So 10, 11, 12, etc. In classical addressing, there's a 10, 11, 12, 13, and 14. So on to classless VLSM. This is variable length subnet mask. So now the addressing uses variable length subnet mask. You don't have to use the default mask. You can move that subnet mask to the left or to the right. And so what it does, it creates multiple subnets from a network address. So you can take a top level network address and it's subnetted when you're using VLSMs to create a bunch of separate network addresses from a single network address. And you can manage the IP address space a lot more efficiently and adjust it from the number of hosts you want. And you can use multiple different length subnet masks within the same network and multiple networks. The routing table is a lot smaller, it's a lot more efficient as mentioned. And this is accomplished by advertising the subnet mask in the routing updates. And so it goes into the routing table, so you get a better routing table, much more effective, much more optimized. But it is advertised with the routing updates, and that's what makes it exclusively different from Classful. OSPF and ISIS support only class lists currently, and the older ones, ERGRP and RIP v2, support Classful and classes, so you can select either. Typically, as your network gets larger, you're going to use class lists. And here's an example here. This is a Class C address, 192.168.1.0. And what happens is from this one address, it's subnetted, so you still got the one there. It's using some of the bits in the last octet to create new network addresses, .8, 16, 20. Now these are network addresses, so the next one, the first host address would be 1.9, or here would be 1.17. This is where you get the host addresses from, and it moves from one range to the next. So VLSMs, for example, here's 24 bits, so we know that's a Class C default mask with 8 bits and 24 bits network. Now if I move this over to include 2 bits in the fourth octet, so now I've only got 6 bits for the host and 2 bits I'm going to use for subnetting. And that's basically all it is. It's just moving it into the octet where typically host bits are assigned. So you can take something like this 1.64, that's something that's subnetted from the 1 dot address, and 65 would be the first host address available, and the 64 network address would be advertised like that. In the IP address components, for example, kind of the same thing. That 64 is the subnet address, 65 is the first host address. It's using a /26 subnet mask, so it's moving 2 past the 24 to include bits into the fourth octet. And there's the mask. The next subnet would be 128. So the last host address there would be 127, and 128 starts a new subnet with 129 as the host interface address. And here's an example here. I can use /30, giving me only 2 interfaces here, 2 host interfaces. /30 takes the subnet mask right over to the right, so there's very little left of the fourth octet. And I can assign /29. That gives me a few more hosts for some redundant links for network interfaces. And then the 16 is a lot more subnets for various wireless subnets. You can group 10 of them into one subnet, 10 into another. And 27 and 26, those are more hosts, so you can get more from 26, you can get more hosts and fewer subnets. And that's basically what I'm doing by changing the subnet mask. This is all on the same network. Bolded here, those are the actual network addresses that I've created from that 1 dot address. And we'll go to Class B. It's the same thing. I can move any bits I want, into the fourth octet, right up to practically /30. This is a 29, so I've got 3 host bits. So for example, 172.16.1.8, then that's a network address. It's a /29, so I'm subnetting into the fourth octet again. And 1.9 would be the first host address, and 1.8 is what's advertised. And here you can see that 1.8, 1.9 is the first host interface. And here the next subnet range would start at 16. And I'll talk about multiples and where it starts at. The multiple is based on where the subnet bits start at. So that's the host address, 172.16.1.17. That's a host interface, and 16 is the network address for that range. Here's an example of Class B addressing, 172.16.1.4. So it's its fourth octet where I'm getting the network address now. .4, .8, .16, .32, 64. They're multiples within each range, and I'll go into a little bit more about that. It'll make more sense. And for class A, there's the 8 bits. That's the default mask with 24 host bits. And this time I'm moving from 8 bits, I'm moving to 27 bits. So I'm moving right into the 4th octet again. I've only got 5 bits, so I'm using the rest of the bits for host bits for subnetting purposes. So I'm going 2nd, 3rd, and 4th octet. So it's quite a bit there. Quite a few subnets that I can create from 27 bits instead of 8 bits. And that's the reason why I'm doing it. I don't need this many hosts, I just need a few. And I'm using a 27 here. So 1.32 is an example of one of the network addresses I can get within /27. And then there's the host address 33. And what's advertised is 10.10.132, the network address. And here the subnet is 32, and there's 33, my first host interface. Then 64 would be the next one, and 65. And pretty much shows you here the 33 is the host number, and 10.10.1 was the network address. And addressing is the same thing. I've got variable masks based on the number of hosts I want to that are required for each VLAN, and that's pretty much all there is to it. This time I'm just using a class A address to do the same thing. And subnet mask shifting, I've kind of talked about this already. I'm using a non-default subnet mask for an address class, and so I'm just shifting bits over into this 4th octet. This is /27, so 8, 16, 24, 25, 26, 27. So these 3 bits here I'm using for subnets to create a bunch of subnets, and these 5 bits left are for hosts. So now I'm going to start with some examples from each class address. This will give you a better idea of how to go through and start creating subnets and how to do the calculations for them. So this first example is a class C address, and I want to create subnets from 192.168.1.0 /24, so each will have a maximum of 10 host addresses for these 3 VLANs. So I'm going to use this top level network address. It's a /24 default subnet mask, and I'm going to go through and use subnetting to create a bunch of subnets to these different VLANs, wireless, user, and server. So here's a topology. There's a layer 2 switch. This is a wireless access point. Often there's 5 wireless access points, for example. This is VLAN 11. This is a user VLAN, so it's got some desktops. And this is a server VLAN with some servers. So the first step is calculate the subnet mask required for 10 hosts per subnet. So I'm going to start with knowing how many hosts do I need for that subnet. First question. Then I want to calculate that subnet mask. I want to know what subnet mask I need to create that. So there's your trusty subnetting table. We'll locate the hosts. I want 10 hosts. So if I go to this column, 6 isn't going to be enough, so I have to go to the next one. That's 14. It's a little bit more, but it gives you some extra. So that is the subnet. That's 4 host bits then in the 4th octet, and 4 bits assigned to subnet bits. It's a /28 mask, so I'm going to make note of that, the length of the mask. So the subnet mask calculation. So the subnetting table, we've gone through to identify the mask required for 10 host bits. That's /28. So 4 bits are assigned to the host, because there's 8 bits in an octet, and the other 4 are assigned to subnetting. That's shown right there. There's the host bits in red, and the 4 bits are what's left over from the 4th octet for subnetting. And I can get up to 14 hosts, so that's within the requirement for 10 hosts, so that's fine. It's /28, adding up these 4 bits based on position. Number of hosts calculation. So I'm going to calculate hosts here, starting from the right. I'm going to show you how that works to the left and add the bits to calculate the number of hosts. This is the binary. Remember the binary table: 1, 2, 4, 8, 16, 32, 64, 128. I'm counting the number of addresses. So if I go 1, 2, 4, and 8, that gives me 15 possible addresses, and then the number 0, that's 16. So 16 possible addresses I can get as I start flipping these bits between them, between 1s and 0s. So that's 16 minus 2, the network and broadcast address, will give me 14 host addresses available. And calculate the number of bits available for subnets then. So we know that there's /28, there's 4 subnet bits, and that gives me 16 possible subnets. So only 4 bits are assigned to hosts instead of 8 bits. And there are 4 bits available for subnetting for the 4th octet, and there it is there pointing to these 4. So that's what I have to work with. Another way of looking at it is 2 to 4 is 16, with a maximum of 14 hosts per subnet, or VLAN in this case. So that's easy enough. So you can assign 16 different subnets from network address 192.168.1.0, and that's interesting to be able to do that. In this case, I only need 3 subnets because I've got 3 VLANs, and I can assign 14 hosts per VLAN. I can use the additional for expansion purposes, for example. Step 3 is identify the subnet multiple to assign subnets. This is a key part of understanding how subnetting works. So the subnet multiple starts at bit 5 from the right. So these are the subnet bits. So bit 5, know what that bit position is. It's 16 right there. So that's my multiple because that's the bit position. And that's the value of the bit position. Well, that's the first bit. So 16, so you just keep adding on 16 as you go along, and that gives you the network addresses. And there's 16 subnets available. We already got that from the table. And so if you count these, you get 16 different subnets. So step 4, calculate the network address, broadcast address, and host address range per subnet. So there's the 0 subnet, and that's 192.168.1.0/28. So that's the 0 subnet. Although the multiple starts at 16, there's always a 0 subnet you can use. It starts things off. Number of hosts is 14. Subnet multiple is 16. So I know what my multiple is. I know the number of hosts for the host range. And from all that, I can create every subnet that I want to apply to the network address. There's the first 0 subnet because it's /28. Now I'm using 1 here. It's a 1 address. I could have used 2 or something else, but for this example I said let's use 1.0, but I could have any of these 2, 3, 4, anything else as a top level network address. And that'll give me 16 subnets. I'm going to assign the 0 subnet to the wireless VLAN. And the network address, there's the 0 subnet. .1 is the first host address available to assign to an interface, to a wireless access point, and it goes up to 14 because there's 14 host addresses in this range, and 15 is the broadcast address. So if you know that that's 15, then the next one has to be 16. That's the 16 address, and 16 starts with 7, goes from 17 through .30. There's the 14 host addresses for that range, and then 31 is your broadcast, and then it goes on to 32. And that'll be assigned to the server VLAN. 192.168.1.32 is a network address, and 33 is starting at the first host IP address available, and that goes through to 46 because there's 14 addresses, and 47 is the broadcast address. The next subnet would be .48 if you wanted to add, say, another server VLAN. So the addressing, there's the layer 2 switch again, the topology. And VLAN 10, that's the wireless VLAN, and it's assigned the 0 subnet /28. VLAN 11, I've assigned the 16 subnet, and VLAN 12 is assigned the 32 subnet. So this is another example. I'm still in class C address. It's the second example. It's got 60 hosts now. The question here is, how do you create subnets from network address 192.168.10.0/24, so each will have a maximum of 60 host addresses for the following VLANs. So in this case I've got 4 user VLANs, so there are a bunch of desktops in each, basically, different groups, departments, and each has a VLAN assigned. And I want to assign 60 host IP addresses to assign to those different desktop, laptop, mobile devices. And keep in mind, most of them will be part of a DHCP server pool. So when I create these host IP address ranges, this will be used to assign them to DHCP server pools to assign within each of these subnets. And so part of that is understanding how to configure a DHCP server pool. You have to know what IP addresses and what the ranges are to do that. So I've got 4 VLANs, 60 host IP addresses per VLAN, and starting with this this address here. In a layer 2 switch, I've got the 4 VLANs here, 9 through 12. So it's pretty straightforward. It's very typical of what you're going to get with a switch. So step 1, calculate the subnet mask required for 60 hosts per subnet. So I want to know what the subnet mask is. I need 60 hosts per subnet. So going through this again, let's go to the far right here. I need 60 subnets. 30 is not going to do it, so what's the next one? 62. That'll do it. So go over, there's a /26 mask. That's a dotted notation there, 192. So the /26 gives me 62, so that'll work. So there's 6 host bits required to give me those hosts, and that leaves 2 bits left for subnet bits, and that'll be 4 subnets. So subnet mask calculation, I'm going to a subnetting table. We know that with 60 hosts, it's a /26 subnet mask required. So taking a look graphically here, there's a /26. That's called CIDR notation, but it's just telling me how many bits there are. So 8, 16, 24, and into the 4th octet with 2 bits. That's 20/26. So that's the length of the subnet mask. 6 bits are available for assigning to hosts, and 2 for subnets. So let's start with the host calculation. From the far right, this is the host. There's 6 of them, 6 bits available to assign to host addresses. So if I start counting 1, 2, 4, 8, 16, and 32, there are my 6 bits and the values associated with them, and they add up to 63. And then the number 0 is another address available for 64 possible addresses I can assign. And 64, and I have to subtract the network and broadcast address, so that gives me the 62 host addresses available. So step 2, calculate the number of bits available for subnets. So I'm going to now calculate, I know that from the table, I'm going to go to /26, so I have 2 subnet bits, and that's 4 subnets available. 4 subnets means 4 VLANs, so that'll work well for that. So there's only 4 available. So in this case, there's the 2 subnet bits, 2 leftmost bits bolded, and that'll give me 2 to the 2 equals 4 subnets. So you can assign 4 different subnets from this network address. So I'm going to start out with that 192.168.10.0 class C address. It's a classful address that I've started with /24, and I'm going to use VLSMs or classless subnetting to create 4 different subnets from that single network address. And each subnet is a network address with a maximum of 62 host interface addresses available. And some devices, keep in mind, require more than 1 host IP address. You have servers that can use NIC teaming, for example, and that'll use 2 IP addresses. In some cases, you've got routers and layer 3 switches that use a lot of host interfaces. So it's just desktops that typically will use only a single IP address. So step 3, identify the subnet multiple to assign subnets. So we're going to go over and figure out, okay, what's our subnet multiple? Well, it's that first bit there as a part of my subnetting bits. Position is 7, but it's the value is 64. So 64 is the multiple. And there's only 4, so there's the 0 subnet, 64, then double it to 128, and then 192. And you can just see on this binary table, I keep including it because just to show you the bit position and what the value is, and to know that really well. But it's easy enough. Like I said, it just keeps doubling as you go from right to left. Step 4, so I'm going to calculate the network address, broadcast address, and host range for each subnet. So I'm going to start with the 0 subnet, 10.0/26. That's my 0 subnet, and the number of hosts is 62 available, and 64 is the subnet multiple. So I know the multiple, I know the number of hosts I can assign each subnet, and that allows me to calculate all of the subnets. So I started out with 192.168.10.0/24. Now I'm going to use a /26 subnet mask. I just showed here again, I used 10 for the example, but I used 11. So I get 4 subnets. We already know that. So 4 subnets. I'm going to start with the 0 subnet and assign that to VLAN 9. So that's 192.168.10/26. So the first host address available, this is the range. Now the host range would be .1 through to .62. And that gives me the 62 host addresses. And that's what you'd use for the DHCP server pool. And 63 is the next one, and that would be the broadcast address. Then going on to 64 subnet, that's the next subnet. And then 65 through 126 is the next subnet range of host IP addresses. And then on to 127. And the 127 is the broadcast. User VLAN 11, I've signed 128 subnet there. And so there's, like I said, there's a 128 subnet, the 192. It just shows you the host address range. It's pretty straightforward. There's 4 subnets, and this is the VLANs that they're assigned to. Here's an example of how I'm going to assign them. So there's 0 is the VLAN 9, VLAN 10 is 64, and VLAN 11 is 128, and VLAN 12 is .192. They're all network addresses. So this third example of a Class C address subnetting, now I've got 225 hosts. So this will be actually a classical subnetting example. So I've gone, and you'll find out that this isn't something that's subnetted, it's just there's 225 hosts, and so there's implications for the number of hosts and how that affects the subnet mask. So I want 2 subnets from this network address 192.168.00/24. So that's a Class C address. It's got a default subnet mask of 24, and that's what we're going to start with. And I want 225 host addresses per subnet. So it's going to be a big broadcast domain, probably a lot of desktops and some other devices. And I'm going to assign the 2 subnets. One's going to be a data VLAN, and the other one's going to be a voice VLAN. So these are the IP phones. So here's an example here. And this is data and voice traffic. The IP phones are separated from the traffic from VoIP is separated from the data VLANs. They'll be on separate subnets. The desktop is connected to the IP phone. The IP phone is then connected to a switch, and each has its own. They're in their own VLAN. So somebody who's got a phone, that VLAN is going to be in its own subnet VLAN to separate that voice traffic. So the first step is calculate the subnet mask required for 225 hosts. So that's our first stop. We'll go to the subnetting table, and 126 not going to do it, so I'm going to have to go right up to 254. So in this example, and this happens sometimes where in essence I'm not going to have something that's subnetted. I'm going to have to go with a /24 default mask because of the number of hosts that are required. I have to use all 8 bits, and it's only going to be one subnet, so it won't be subnetted in essence. So to start with this, it's going to be a classical subnet mask because it's /24 for that Class C address. It's default. So all 8 bits are going to be assigned to the host. I'm not going to move into that 4th octet because I need so many hosts this time, more than the 126. And so there's the first 3 octets, and that's the /24. So this 3rd octet's going to be the variable number I'm going to use, and that'll give me up to 254 available hosts. So the host calculation makes it a little easier, I guess. It's I'm going to add up all 8 bits. All of these are all 8 bits of the octet, and that gives me 255. And the number 0 is a number as well as assignable, so that's it's a number that's that has to be included as part of binary math, if you want to think of it like that. So technically there's 256 possible addresses, and that's 2 to the power of 8, 256, minus 2 for the network and broadcast address that are not assignable to any host IP interface, desktop or whatever it is. And that leaves me with the 254 host IP addresses I have available for assignment to that subnet. So the step 2, I'm going to assign network addresses from 192.168.0.0.24. So I'm back to my address here, and now I have to figure out how I'm going to subnet it. What subnet I'm going to use. So the subnet allocation. So for the data VLAN, so the 8 bits. This in bold here is actually the subnet number that I have to select. So in this case, I've selected 9, for instance. So I'm going to select 9.0/24, and that's what I'm going to use for it. In a sense, it's not really calculation so much as just really deciding on what number we want to use in that third octet. And so I decided 9. There's the there's the host addresses. That's the number that's going to be the subnet number the router's going to use. And on to the voice VLAN. In this case, I'm going to use 10.0 for the voice VLAN. I could have used anything between 1 and 255, but I chose 10 because it matches the VLAN number. And so there's the 10 there. That just shows where the subnet is being derived from, that third octet. And I've got all these for host addresses for VLAN for the 10.subnet. So calculate network address, broadcast address, and host address range per VLAN or subnet. So the data VLAN, I've gone with 9.0 for this. I've chosen to use 9. It matches the subnet. And then it's just 1 through 255. That's all there is to it. It's easy to calculate. It's just deciding what subnet number you want to use and why you want to use it. In this case, I'm going to match the VLAN number, so I use 10 for the voice VLAN, and 10.1 is the first host IP address, and right through to 254, and the broadcast address is 255. And that's really all there is to it. If I want to add more, I can continue adding subnets, and that's typically how that works with Class C addressing in that /24. You keep assigning subnets. So there's 127 additional branch offices. So if I've got 2 VLANs, in this case I've got 2 VLANs per office, and I've got so that's consider there's 128 branch offices, and so I'm going to start assigning these. So the next branch office could use 11 for the data VLAN and 12 for the voice VLAN. So that gives me up to, so if I've got 2 subnets per 2 subnets per branch offices times 128, that's 256 different subnets, and that's for Class C address. So that gives you an idea of how I would assign them, 2 per address, 2 per branch office, and just keep assigning available numbers so they don't overlap, and it's just easy enough to do that. And there's the 9.0, and there's the 10 assigned to the VoIP traffic, and that's really all there is to it. First video on Class B addresses for subnetting. I'm going to start with this example of 5 hosts. So I've gone into start using Class B addresses. So I want 5 hosts. That's my example. I want 5 subnets from this Class B address. The main thing to know that it is Class B that I'm subnetting, and I'm going to move into the 4th octet to use that Class B address and for subnetting purposes. And each subnet is going to have 5 host addresses, so 5 subnets and 5 host addresses per subnet. So here's an example. Here's some layer 3 interconnects. Each of these is a broadcast domain. So in this case, I've got 5 subnets. This one between these layer 3 switches, and I've got one between switches, between the router and switch, and then one between these 2 routers. And a lot of these additional interfaces are used for redundancy and load balancing. So they're a bunch of layer 3 interconnects, so I'm going to assign IP addresses to them, but I don't need a lot of host addresses to do it. So what's the subnet mask for 5 hosts per subnet? So on the table, start over here, and 2's not enough, so I have to go to the next one. That's 6 hosts, so that'll work. That's what I'll use, and that's 3 host bits are used for the host addresses and 5 for subnet bits. And it's a /29. So the subnet mask over here, I've got 3 bits available for host addressing, and I've got 5 bits available for subnets. And so that's easy enough. It'll give me actually 7 host addresses, but I'm only going to use 5. So number of host calculations, so starting from the right, so that's 1, 2, and 4, that's where I'm getting the 7 from, plus the number 0 is 8 addresses, minus the 2 that I have to subtract for network and broadcast. That's where I get the 6 from the subnetting table. So 6 addresses available. And I'm going to calculate the number of bits available for subnets. So through here, I've done this already, but I'll show you 5 subnet bits and 32 subnets. So that does the calculation for me. I know it's 32 subnets available. And that's a lot more than I need, but that's what I have to use to get only a smaller number of hosts that I really only require. So there's the 5 leftmost bits. That's the 5 bits I'm going to use for subnets. And there's the 3 bits for hosts. 2 to the 5 is 32. That's just more of the binary math, where you get the 32 subnets from. And there's a maximum of 6 hosts per subnet. So you've got 32 different subnets, so lots more interconnects you can add with 32 different subnets as your network gets more complex, and you're doing it from that single network address. So identify the subnet multiple to assign subnets. The subnet mask is /29, so 5 bits past the 24, so there it is there. So 1, 2, 4, and there's 8. So there's the bit position 4 has a value of 8, so that's the multiple right there. So 8, 16, 24, just keep adding 8, and that'll give you the subnets. There's 32 available, as we know from the subnetting table. So now to calculate the network address, broadcast, and host range. So we know that 0 subnets available, and you can start with that if you want to. There's 6 hosts per subnet, and there's my multiple. So I started out with this /24. What it does, it denotes the fact that I'm taking a class B, converting it into a class C address. So what I have to do, if I do that, I'm extending the subnet mask along to the 4th octet. But I do have to assign something to that 3rd octet, and it's arbitrary as well. It's 1 through 255 possible numbers. I chose 1, but I could have chose 2 or 3 or something else. The other thing I could have done is I could have chose 172.17.1 as well, because that's still within the private IP address range of 172.16 to 172.31. So these are somewhat arbitrary, but often they're selected for good reasons as well. So it's a little of both, and there's 32 subnets I'm going to generate from that. So there's 5 subnets, each defined. I've got the interconnects that require 5 subnets altogether based on the network design. And there's my 0 subnet, so 172.16.1.0/29. Then the host range starts at 1 through 6, because that's the number of host addresses, and 7 for the broadcast. We've gone through this one's video, so you kind of know how it works now. There's the .8, .16, .24, and .32 address. I've got 32 subnets, so I'm only using 5 currently, and that's how I would assign them. So this would be the 0 subnet. There's the .8, 16, 24, and 32. Often a data center, for example, where you get this kind of complexity. This time I'm going to increase the number of hosts to 25. And so I want to create some subnets from network address 172.16.1.0, my class B address. So each will have 25 host addresses for these following user VLANs. And these are 4 VLANs. Each of them have a variety of desktop, laptops, maybe mobile access devices, a variety of things. And so they're user VLANs. And there's my topology, and there's 4 VLANs. So that means 4 subnets. There's a layer 2 switch. So I want to calculate the subnet mask required for 25 hosts per subnet. So I want to know what that subnet mask is to give me those 25 hosts. So we'll go to my subnetting table. Get to 14 is not enough, so I have to go to 30 hosts. And what's 30 hosts? Go over here, and that's a /27 mask. It's 5 host bits. I'm going to be doing a /27 mask for this example. And /27 means there's 5 host bit here in red, and 3, whatever's left, 3, is available for subnet bits. So that's the host portion there, and that'll give me 30 host address. And the /27, and that's the subnet mask length. So the number of host calculations, starting from the right, 5 bits assigned here from the right. So from the right, I'm going to add up the first 5 bits, the values for each bit position. And that'll give me 31, 16, 8, 4, 2, and 1. I'm going to add the number 0, and that gives me 32 addresses, possible addresses. However, there has to be 2 subtracted for the network and broadcast address that are not assignable. And so that gives me the 30 host addresses, so that'll work for our example. It's a little bit more than the 25, but there's certainly nothing wrong with that. So we'll calculate the number of subnets. So in this case, I know I've got a /27 mask. That's 3 subnet bits that are available. There's 8 bits per octet. So the 3 subnet bits gives me a total of 8 subnets available. So those 3 left bits, I'm going to subnet those. So 8 different subnets, or VLANs in this case. We're creating 8 from this 172.16.1.0 Class B address with 30 hosts per subnet or per VLAN. And now I need to identify the subnet multiple to assign to subnets. The multiple is something that's required to do the calculation when we start specifying each subnet, how we're going to assign addressing. So in this case, there's 5 bits for hosts, and these 3 here for subnets. So starting at bit position 6, that value would be 32. That's bit position 6. So just quick reference there. That's the value of it. And so there's 8 subnets available, 0, 32, 64, 96. I'm just adding 32 because it's a multiple. So there's 8 subnets from 0 right through to 224. That's where I'm getting the 8 subnet available to, or network addresses. They're synonymous. And step 4, calculate the network address, broadcast address, and host address range per subnet. So here I'm going to start again with the 0 subnet. So 172.16.1.0/27 is the 0 subnet, and there's 30 hosts within that subnet that are assignable. Multiple is 32, and I'm going to get 8 subnets. So in this case, I've got the 4 user VLANs, 9 through 12. So 9 is going to get the 0 subnet, 10 is going to get the 32 subnet, and 11 will get the 64 subnet, and 12 will get 96 subnet. The same process. You start with 0, and then you add 1 through 30, and that's the host range, and then 31, and then so on for each one. All 4 subnets are accounted for. So you've got the host IP address range and network and broadcast address, and that's all you need to define a subnet. And here's just a picture of how I'm going to assign the addresses. And these are the network addresses, subnetted network addresses, if you like, 0, 32, 64, and 96. That's all easy enough, and there's room for adding 4 more because I've got 8 subnets available. So this is the last example of the Class B addressing, and I've gone right up to 300 hosts. So this will make it interesting. I want to use a Class B address. In this case, you found out I have to use a Class B address. There's 300 hosts, but I want to create 4 subnets from 172.16, and this is just denotes notation for what is a Class B address. I'm just starting 172.16. I could have went 172.16 1.0/24, but I'm just going to start 172.16. Very high level address. And I want to assign 300 hosts per subnet. And there's 3 user VLANs and 1 server VLAN. So there's a server VLAN in this example, but I want 300 hosts available for each. So there's the 3 user VLANs. Those are multiple desktops per VLAN, and there's the server VLAN with a bunch of servers. That's what that denotes. And so step 1, calculate the subnet mask required for 300 hosts. So it gets a little interesting here, so I'm going right up to 254. So I realize I can't even use the /24, so this Class C subnetting table is not going to work. 254 is not enough. So I'm going to go to Class B subnetting table. In this case, that'll work. That's 510, so that's the option that I have to use. And that requires 9 host bits. So I've moved out of the 4th octet into the 3rd octet at this point. And that's a /23 now instead of /24. So that'll work okay. And the calculations, you see now this is the hosts here. So there's 8 here. And then into the 3rd octet, and that's Class B country, so that's 9 now. So that's 9 host addresses I've got to assign just to get that higher number of host addresses. It's 9 bits. So the subnet mask is /23, so that's what I'm going to have to use now. And that's 8, 16, and the 7 is 23. Those are the bolded numbers there. So host calculation, it's 1, 2, 4, 8, 16, 32, 64, and 128. The 256 is just the double the 128, and that's into the third octet. So I just have to double them. If I add them up, I'll get 511, and the number 0 makes 512, and minus the 2 for the network and broadcast address that's not assignable gives me the 510 host IP addresses, and that's a maximum. I only need 300, so I've got some extra there for sure. And calculate number of bits available for subnets. So in this case, I'm on my Class B subnetting table. I've got 7 bits available, and that's in the third octet. In this example, I'm going to subnet the third octet, and I've got 7 bits left there for subnetting. And that's a lot, and that gives me 128 subnets. So 128 subnets with 300 hosts per subnet is a lot. Very scalable. So those 7 subnetted bits now, but I'm in the third octet, and that's all bolded, and 2 to the 7 is 128 with 510 hosts per each subnet. So there it is there, 172.16/23, and how I'm going to start deriving subnets. So I have to get the multiple to assign subnet. That's the next thing I have to do. What's the multiple? Well, in this case, it's bit 10. So there's 9 bits to host, and then bit 10 is that bit there. I'm into a new octet, because these are only octet binary tables. It works per octet. So if I'm in the third octet, there's the 2 value there, because it's in the second position of that octet. Second one over. That's what that is. So my multiple, bit 10, so the multiple gives me 128 subnets, because it's 0, 2, 4, 6. So there's a lot of them. Half of 256 really, in numerical value. Each one is just like the multiples to 128 subnets. So I'm going to calculate the network address, broadcast address, and host address range per subnet. So going through here, I've started with 172.16.00/23. That's my 0 subnet. And then I'm going to go to 0.1 to 254. So that's the 254 there. But notice here what makes this interesting. It's important to notice that this is the 0.1, is you have to go into the third octet. So it's actually the subnet does change within the host range. And that allows me to get more than the 254. And there's the 1.255. And then so for user VLAN 10, the next one's going to be a multiple that starts at 2. And then so it's 2.1 through to 3.254. So that subnet changed again on me, but it will do that because with binary math, I'm using more than 254 hosts, or requiring it. So I'm going into another subnet, so the subnet changes within that host range, in essence. And there's my broadcast address. And if you do subnet calculator, you'll see it graphically as well. It'll probably make more sense. And there's the 4 subnet and the 6 subnet, VLAN 11 and server VLAN 12. And the same thing here, you'll notice this subnet changes from 4.1 to 5.254. That is an address range of 510 hosts, just like all of them are. And in this example, I'm just showing the actual network addresses. There's 0, there's 2, there's 4, and there's 6. And those are the 4. And like I said, there's 128, so there's a lot more that are assignable. So now I've moved into Class A addressing and giving you some examples of some typical kind of subnetting for each class. So I'm going to start this group of Class A addresses with 2 hosts. It's called the WAN interface mask. So I'm going to create WAN subnets, or 10 branch offices, from network address 10.1.1/0. I'm going to start with a Class A address, and that's what that is. And I only want 2 host addresses. This WAN subnet has 2 routers, and each router has a WAN interface. So there's only 2 host addresses required per that WAN subnet or WAN link. So here's an example. There's the data center there, and I've got 10 branch offices. Each of these have a separate WAN link, therefore a separate WAN subnet. It's just another broadcast domain. And that's currently the topology, hub and spoke. And step 1, I want to calculate the subnet mask for 2 hosts. So that's easy enough. I'll just go, and in this case it is a /30 and 6 subnet bits, so that gives me 64 subnets and 2 host bits per subnet. So there it is there. There's the 2 hosts. So that's just the 2 bits that I can use for hosts. And the other 6 bits are for subnets. So the host calculation is easy. It's just the first 2 bits, and that gives me 3 plus the number 0 equals 4 addresses. And I subtract 2 for the network and broadcast, and that's where I only get 2 host addresses that I can assign. And step 2, calculate the number of bits available for subnets. So in this case, this is kind of key too, because there are often a lot of WAN links connecting branch offices, so you want lots of subnets. So I've got 6 subnets available for a maximum of 64 subnets. So think of it as 64 branch offices. I only want 10, so there's lots of room for expansion. So that's a good thing to keep in mind. So there's the 2 bits available for hosts and 6 bits available for subnetting. 2 to the 6 is 64. So that's just very standard network design right there. So you've got 64 subnets I'm going to assign or create from that one Class A address for WAN connections. So what's the subnet multiple to assign subnets? Start creating my ranges. Well, in this case, third bit position 3, what's that? Well, that's a 4 for bit position 3, so there's my multiple. And that gives me a lot of subnets, 64 altogether, 0 through 252. So lots of subnets available. And I'm going to calculate my network broadcast and host addresses. The 0 subnet is going to be 10.110/30. That's my first subnet that I'm going to start with. And there's 2 hosts only. And the multiple is 4 to start creating the other subnets. In this case, I just like to show you just how I can change these different numbers if I had wanted to. 10.1.1, I can get 64. If I needed 64 more, I would go with a 10.1.2, and I can derive a bunch of 64 subnets from that. Or I could do 10.2.1 for another 64. So you see how with 10.x addressing, so much you can do with them, because there's so many octets available for numbering, within the second and third octet for a new subnet range, 64 more. I just changed this to a 2, for example. So there's the 0 subnet, and 10.110/30, that's 0. Then 1 and 2 are assigned to the host range, and 3 is the broadcast. And then there's the 4, and then that'll go right through after 4, or 8, 12, 16, so it's multiples of 4. That's 10.1.15 would go to a local router, and 10.1.16 would go to the remote router. Anytime you have a WAN link or any layer 3 link between 2 devices, you have to have them in the same subnet. You can't have them in different subnets. And 10.1.17 is the broadcast address, and it goes right up to 252, and then there's 253 and 254 available for assignment, and 255 is the end of the range, or 10.1.1. And so that's what I would get. I've got a branch office data center. I'm going to assign 10.1.1.1 to that branch office router, and 10.1.1.2 to the data center router. And it'll work quite well, and that's really all there is to it. In this example here, I'm just showing you the all 10 branch offices. There are 10 subnets equals 10 WAN links. So I got up to 36, and that's all I really need to do because there's only 10 offices. So in this example, this is a Class A address. This is the second example in this series of Class A addresses I'm going to subnet. And I'm going from 2 hosts to 100 hosts in this example that I want to create subnets for Class A address. So I want 2 subnets from network address 10 to 10.1.0. So each subnet will have 100 host addresses. So there's a user VLAN 11 and a user VLAN 12. So I've got a lot of hosts in this case. I've got 2 user VLANs, 100 hosts each, just 2 VLANs. And I want to calculate the subnet mask that I need for 100 hosts. So in this case I need 100 hosts, so that's a lot, but it's right at the top of the table. The 126 will work, so that's like 126 hosts requires a /25 subnet mask. That's 7 host bits. So that's what I'm going to use, /25. So the subnetting table shows me that I have to assign 7 bits to the hosts, and only 1 bit is available for the subnets. So to calculate the host, it's the first 7 bits, and that gives me 127, plus the number 0 is 128, minus 2 for the network and broadcast, and that's the 126, gives me the maximum number of host addresses available, which is of course more than the 100 required. So calculate the number of bits available for subnets. So back to my table, if I go to /25, that's what I'd have to use. There's only 1 bit available for subnets, and that gives me 2 subnets. So that's not a lot. There's a lot of hosts though, so it's used a lot of times for larger user VLANs where I'm still using subnetting. So there's the 7 bits, and there's the 1 for the and it's only 1 bit, so a 0, 0 and 1, or 2 values, /25. So I'm creating 2 different subnets from that class A address, and each one is going to have up to 126 host addresses or interfaces, if you want to think of it like that. So what's the subnet multiple? That's the next question. So the subnet multiple, I need to go over to beat position 8, and what is that? That's 128. So easy enough. I know the multiple is 128. So there it is, 0 and 128. And this was often used a lot just to take a switch, a layer 2 switch, and just carve up 2 VLANs, and so you put each one user in one VLAN and another one in another, just so you don't have 250 some in a single VLAN. It's just much better designed to put user groups into smaller VLANs, and so you'd set up a switch and assign one group to 0 and the other one to 128. It's a common practice. So calculate the network address, broadcast, and host address range. So I know my multiple is 128. And again, I just wanted to describe how this numbering works. It's a little bit arbitrary. There's so much of it available. I could have went 10.20.1 if I wanted to. I decided to go with .1, but I could have went with .2. If I needed more than 2 subnets, if there's more switches, then I would go to 10.2, for example, and do the same thing all over again. Or I go to 21, 25, there's lots available there. I just want to show how the number works and how you would jump to the next group of subnets. To the assignment VLAN 11, the 0 subnet, so there it is there, 10.10.1.0. And that's 1 through 126 and 127 for the broadcast. And 128 is the next subnet network address. And then 129 through 254 is that host range. And then 255 is the end of that range. After that you'd have to go to 10.10.2, for example. And that's how I've got it assigned. There's the 0 subnet, and there's the 128 subnet, only 2 of them, /25. This is my third and last example from Class A addressing. In this example I want to do 150 hosts. So I want to create subnets from network address 10.10.00 and assign 150 host addresses to each of the VLANs. So in this case I've got a user VLAN and I've got 2 server VLANs. So 150 hosts per each. So a lot of servers, probably a server farm. So there's VLAN 10, that's the user VLAN with a bunch of desktops. And this is the 2 servers with a lot of servers, a bunch of web servers, for example, and they're connected to a layer 2 switch. So step 1, calculate the subnet mask required for 150 hosts. So easy enough. I'm going to go to here. In this case 126 is where subnetting really starts for the Class C addressing, but that's not enough, so I'm going to have to go to 254. So I'm back to a classful address, although in this case it's Class A, so it's not really classful, it's classless, because /24 is not the default mask for a Class A address, so it's really classless. So you have to kind of think of it like that. I'm moving a Class A address into an octet where it typically doesn't go. So it's Class C subnetting of a Class A address. And so that'll give me all the addresses. So the subnet mask calculation. So what I'm going to do here, I've got 150 host bits. So I'm going to use all 8 bits here to get me that 150. So what I do then is this third octet is where I'm going to start creating some subnets. So number of host calculation, it's all 8 bits. So that's 255 plus number 0, so that's 256. Minus the 2 is the 254 host IP addresses as a maximum. So I'm going to assign network addressing from 10.10.00. And there's my subnet allocation, the user VLAN. So in this case, I've got the user VLAN. I'm going to assign 10 to it. So there it is there. So it's the 10, and there's the host addresses there. I just need to assign an arbitrary number to that third octet. I want to use 10 subnet, for example. In the server VLANs, 11 and 12, I'm going to assign 11 and 12 because they match the VLAN number. So there it is there. Easy enough to do this. It's not really a calculation, it's just knowing what can be subnetted and what cannot. So this is what's available. And then calculate network address, broadcast address, and host address range for VLAN. So in this case, I've got 10 address for the user VLAN, 11 for server VLAN, server VLAN 12. And each address, each subnet has 1 through 254 addresses. So very straightforward. There's a 10 subnet, there's the 11 subnet, and 12 subnet. In this video, I'm going to go through how to use an IP4 subnet calculator. You can get others that are software based, but the online ones work well. And this is an excellent way to verify your work. And so as an example, Class B address of 172.16.0.0, and I want to know how many hosts. So this example, say I wanted 400 hosts. So what I would do is I would select this one here, 510, that's enough, that's my closest range. And it gives me a /23 address. So that's my subnet mask I would use. Change this to, it'll update. And so there's 172.16.23, that's the IP address or network address, top level. And there's the subnet mask for /23, so you get that, and the wildcard mask as well. And you get the broadcast address. And as a Class B, there's 128 subnets, and the number of IPs is actually 510 that are usable. And that's important to know that. That's very key. And this was part of the addressing of Class B 300 that I used for that particular video that I did. And so here, these are all the subnets. So this is the network address here, 172.16.0.0. This is 0 subnet. So the first is 01. And the last one would be 1.254. Transitions in the third octet to get that 510 number. So I'm into the third octet because there's so many hosts. It's 9 bits assigned to the host. So 1.254 instead of 0.254. And then there's the broadcast. And then the next one would be 2.0. So that gives you, these are giving you the subnets you would use to start creating all those hosts, those subnets that have up to 510 hosts. If my requirement would say 400, then that would do, but I will only get a maximum of 510. And it'll give you the number of subnets. In this case, there is a total of 128, 0 to 127. So this is quite nice, particularly when you get into Class B, large numbers over 254. It helps a lot to have this to verify, and you can do calculate the subnets for you in the host ranges and the broadcast address as well. And another example would be, say, 100.0. So I'll start with that address and say I want to subnet that with do 30 hosts, for instance. So it tells me with 30 hosts I'm going to have to use a /27 mask, so that's okay. Click the submit button here. It'll update it here for me. So there's the IP address and the wildcard. It's nice to have that. Sometimes know what the wildcard is. So it's the broadcast address would be 100.31. And there's the network address 100.0. So the number of subnets is actually 8 subnets. So with a /27, if you go to the table, you'll notice that'll give you 8 subnets and 30 hosts. So those are key values there. So you've got 8 subnets with 30 hosts. So that's what it is you're working with there. And you go through and figure out how that's allocated. There's 0 through 7. So the 0 subnet is 100.0. Then the first usable IP would be .1 through to .30. And 100.31 would be the broadcast address. So when you see the broadcast address listed here, it's showing it for you for the 0 subnet. And as you go through and now further subnetting, you would use .32 is the next subnet. See, there are multiples of 32, 32, 64, and so on. You know what the multiple is there. And then the first host IP for that next subnet would be start at 33 through to 62. That's the 30 host addresses. And there's the broadcast address. In this lecture, I'm going to show you how to configure subnetting. Subnetting is one of the most important topics on the CCNA exam. So with this topology, I've got 3 branch offices, and each branch office has a LAN segment and a WAN segment. So this is branch office 1, branch 1, there's branch 2, and here's branch 3. Each branch office has a LAN segment that has a number of hosts connected. It's all variable. And there's a WAN link to the data center. So what I'm going to do is I'm going to configure subnetting on each branch router as well as the data center router. And subnetting, the purpose of it is to use classless addressing to modify the subnet mask based on the number of network interfaces or hosts that you require on a LAN segment or a WAN segment. So for the WAN segment, I only need 2 hosts. There's an interface on branch 1 and an interface on the data center router. It only requires 2 hosts or 2 network interface addresses. So I'm going to use a /30 subnet mask for that. When it comes to the LAN segment, I've got 12 hosts connected. So there's 12 desktops, for instance. It's a VLAN if you want to think of it like that. So the VLAN's only got 12 desktops. So I'm going to use a subnet mask that only requires that only makes available 12 hosts. That's a /28. Over here I've got more. I've got 25 hosts. So I've got to use a subnet mask of /27. And over here I've got even more hosts, so I have to use a subnet mask of /26. So if we go to I've got a table here I can show you. So these are the WAN segments. So I've got the host names here, all 3 branch offices, and they've got a link to the data center. So I've got 3 different subnet. Each link between a branch office and a data center is a different subnet. I'm going to start with 192.168.16.1 for branch 1, and I'm going to assign the data center side of that link to 16.2. And for branch 2, I'm going to use 16.5, and on the data center end, I'm going to use 16.6. They have to be in the same subnet, and they're each separate subnets. And for branch 3, I'm going to use 16.9, the data center side 16.10. So these are /30 subnets. So for branch 1, the network address would be 16.0. Then I can start using 16.1 and 16.2 for that subnet for host addressing. 16.3 is a broadcast address, so you can't assign the network address or broadcast address to a network interface. So 16.4 would be the network address of the next subnet. So that's for branch 2. So the first IP address available would be 16.5, and then 16.6 for the data center side. And then .7 would be the broadcast address. So the next network address or subnet would be 16.8. So 16.9 would be the first IP that I can assign from that subnet range, and then 16.10. So it's only 2 host addresses per subnet. That's all I need for a WAN link. And these are the interfaces I'm going to assign the IP addresses to. Now on the LAN segments, it's slightly different. These are based on VLANs, or the number of hosts per VLAN. So for branch 1 I've got 12 hosts. So I'm going to start with a network address of 192.168.10.0 for example. And branch 2 is going to use 11.0 and branch 3 is going to use 12.0. So this is going to be for my LAN segment. And these are the interfaces I'm going to start assigning. This is going to be the assignment to the, actually it'll be the default gateway on the router inside interface, the LAN interface I'm going to assign. It's called a default gateway address. So these are the subnet masks I'm going to assign, and this is assigned based on the number of hosts I need for each subnet. So I'll go to the subnet, Class C subnetting table here. If I need 12 hosts, what I do is I do a lookup here, and the closest I can get is 14, and that's a /240 subnet mask. I'm going to get a couple extra, but that's okay. And the next one would be 25 hosts for the VLAN on branch 2. So for that one, I'm going to have to go to the next one. That would be 224 because that'll give me up to 30. So I'll have 5 extra. That's okay. And branch 3 has 60 hosts required, so I need to go to a 192 subnet mask for that, and that'll give me 62 hosts a maximum. So it'll give me a couple extra as well. So what I'm going to do is, the first thing I'm going to do is I'm going to start with the WAN segments between the branch offices and the data center router. I'll start with branch 1 and start configuring interfaces. So we'll go to branch 1, I'll go to the command line, enable, I'm going to sign on, and configure terminal. So the first thing I'm going to do, based on this drawing, I've got 3 WAN segments here. Yes, there's 16.0. These are network addresses, 16.0, 16.4, and 16.8. So I'm going to assign 16.1 to branch 1 interface and 16.2 to the data center. And this is going to be this segment here on branch 2. I'm going to assign 16.5 and 16.6 to the data center side. And on branch 3 I'm going to assign 16.9 because their 16.8 is the network address. So 16.9 to the branch office interface and 16.10 to the data center interface. So I'm going to start over here with branch 1, interface FA10. So that's the interface here. This is going to be 16.1. So it's just an IP address, 192.168.16.1, and then the 255.255.255.252 subnet mask. And that's called a /30 or a serial subnet mask, is what it used to be called. And it just gives 2 interface addresses that are assignable. Then I'll do a no shut, and now that's turned up. So what I want to do is go over to the data center router, assign 16.2. So I'm going to configure terminal. So 00 is the interface. IP address 192.168.16.2 and same subnet mask. Okay, so there's 16.2. So there's 1 and 2. And then a no shut. And interface is turned up. So what I want to do now is I'm going to go over to branch 2. And I want to configure the IP addressing there. So I'm going to start with 10 on branch 2, and that's going to be 16.5. So 192.168.16.5, and then my correct mask. Okay, so 16.5, make sure everything's correct, and then a no shut, and state change to up. I'm going to put 16.6 on the data center router on 10. So I'm just going to go up arrow to 10, interface 10, and this is going to be 16.6. And what else? Then a no shut. And that's fine. Next thing I want to do, I want to go to branch 3, and this is the 16.8. So 16.9 is going to be assigned to FA10. So I'm going to go over here and start that. So interface FA10. Okay. IP address 192.168.16.9. Okay, so it's 16.9, that's correct. Correct interface. And no shut. And it's up. Next thing I want to do is configure 20. So that's going to be 16.10 on the data center router. So I'm just going to up arrow here so I don't make typing mistakes. It's a little easier. So 2.0. And I'm going to IP address right up to 16.10. There it is there. And the mask is correct. And no shut. So that configures the WAN links. So next thing I want to do is I'm going to go over to the branch router now. And I want to do the 2.0 interface. I want to put an interface. These are layer 2 switches. They don't have IP addresses. There is an IP address on the host, of course. So this 2.0 is a default gateway for the VLANs. So that's going to be now LAN segment. So if I go back to my table here, the LAN segments, I'm going to start with branch 1. I'm going to start with 10.0, and so I'm going to assign 10.1 to the 10.1 is already assigned to the host. 10.1 through 10.1 through 10.12, for example. So I can assign 10.13 or 10.14. Or I could just assign 10.1 and then 10.2 to the host address. So in this example, I'll just do 10.1 for the gateway address. So what I'll do is I'm going to assign 2.0 here. There's the interface. So I'm on branch 1, so I want to do 2.0. So I want to go to 2.0 here. And I'm going to do an IP address. 192.168.10. I'm going to assign 1 here. And 255.255.255. And it's a /28, so the /28 mask is a 240. And if you want to verify that, go back here. There it is, it's a 240. I'm assigning here, and that gives me the correct address. Okay, so that's assigned, and I'll just do a no shut. So next available address for the host would be 10.2, and right up to 10.14. So next thing, I'll go to branch 2 and do 2.0 as well. I'm going to find 2.0 there. So that's the default gateway. The IP address is going to be 192.168. This is the 11 subnet now. This is one I'm using 11 here. I'm going to assign 11.1. I'm using a different subnet this time. I'm using another one, /27. And /27 looks at 224. So I have to use 224 there. Okay, so there's 224, 11.1, and the no shot. On branch 3, we do 2.0 as well, so there's the 2.0 interface. So what we do is I'm going to go select 2.0, an IP address 192.168.12.1, because this is using the 12 subnet for the LAN segment on branch 3. And 255.192 is actually the 26 is the subnet mask for the number of hosts of 60. Then I'll do a no shut. Okay, so everything is currently configured. I'm going to go back to hosts. I'm going to change the gateway there to 10.1. And this would be now 10.2. So I had to go with that. Same thing here. I have to configure the right default gateway. So there's 11.1. There's 11.2. 11.2. And over here, the same thing. So the default gateway would now be 12.1. I just decided to start with 12.1 instead of, say, 12.14 or 12.2. So this is the IP address, is the next available IP address. So everything's configured correctly there. Now the next thing is to verify connectivity. So I've turned up some interfaces, so I want to make sure that they're active. So IP interface brief, show IP interface brief. And that'll show me the, so it says 16.1 and 10.1 are up and up. So that would be, so if I'm on branch 1, so that's 1.0 and 2.0. So that's correct. In branch 2, I can do the same thing. Show IP interface brief. So it shows me 1.0 and 2.0 up, and there's the IP addresses. Up and up, that's layer 1 and layer 2. In branch 3, and same thing. Status is layer 1, protocol is layer 2. So 1.0 and 2.0, 16.9, 12.1, that's what I configured there. They're showing as up. If they're up, then the data centers will be up, because you can't have an up and a down. In this case, there's 0, 0, 0, 2, 0, and 3, 0. So 0, 0, actually there's 4. They're all up actually, 0, 0, 1, 0, 2, 0, and 3, 0. So 0, 0, 1, 0, 2, 0, and 3, 0. 3, 0 was the local LAN segment for the data center. So everything looks fine there. So now, what I could do is try pinging something. So here's the data center, 172.16.3.1. So what I can do is go over here in a command prompt. So there's from here, from host, this host here on branch 1, I'm pinging 172.16.3.1. So I got a couple replies, and that typically when you only get a couple, that means the ARP table is just hasn't updated on the routers. So now I'm getting all 4. Notice that. So there's connectivity there. And the next thing I want to do is go over to host 2 or branch office 2 and try to verify there's network connectivity to the data center. I'm going to do the same ping, 172.16.3.1. And so I'm pinging from here right over to the data center. And I'm getting lots of replies, so getting all 4 now to 172.16.3.1. So that verifies layer 3 connectivity over the data center server. And last one I'm going to do is branch office 3. So I'm going to ping the same thing. .3.1. That sends a ping right over there. And I got 3. Let me try it again. There it is, all 4. So I verified the interfaces are up. There is layer 3 connectivity. I could even do something like web browser as well. And that verifies right up to the application layer. So I could do HTTP 172.16.3.1. So this opens up a web page on the onto the data center server. So ping verifies to layer 3. A web page, HTTP, is an application layer protocol, so it verifies right up to the application layer. Just something there to verify as well. So that concludes subnetting.